Good afternoon, class. We are looking at Chapter 2 review, limits and the derivatives for exam 1, which covers 2.1 through 2.8. So the first part, we're going to cover Chapter 2.1 to 2.3, sections 2.1 to 2.3, the tangent and velocity problems, the limit of the function, calculating limits using the limit laws. So this is the whole chapter. So we will cover ultimately the tangent and velocity problems, the limit of a function, calculating limits using the limit laws, the precise definition, continuity, limits at infinity, horizontal asymptotes, derivatives and rates of change, the derivatives as a function. So let's get started with the concept of a limit, and let me give you a summary of a few things. That we want to find limits by various methodologies. A numerical method, graphical method. We also will look at algebraic or analytical method. For now, definition. Limit of f of x as x approaches a is L. Lim stands for the limit. The limit of f of x as x approaches a equals L. That's what we read. At the bottom, we have what's called a one-sided limit. The limit of f of x as x approaches a from the left, and the limit of f of x as x approaches a from the right. If the two are identical, then we say the limit of f of x as x approaches a equals L. What do we find in this part? If the limit of f of x when x approaches a, or a from the left or a from the right, is either negative or positive infinity, we have therefore VA, short for vertical asymptote, x equals a. Let's look at all of this and see the differences among them. And if we understand this graphically, we understand the concept of a limit. Notice this is A, and this is the left side. We are approaching A from the left side. So that's the concept. And when we are approaching A from the left side, that means we are moving in this direction and in this direction along the y-axis. So going this way, that means in this branch we are going this way. We are moving towards this point, and therefore the y coordinate this point. Now, in all of those three cases, when we move from the right side of A, and this one means finding the limit on the right of A, then we are moving here. Okay. And so in all cases, in all three cases, we are moving towards this point. What is the y coordinate? L. That's the limit. Remember, the limit of f of x refers to the y coordinate. All of them have the same limit. What's the difference? This one, f of a is also L, which means it's continuous at A. But in this case, f of a is the y coordinate of this solid point, which is B. We have a hole here, which makes it discontinuous at A. In this case, I don't see any solid point. Therefore, f of A is undefined. And if we can see the differences among those, we are in good shape. So, definition of a continuity is that the limit of f of x when x approaches A equals f of A. And finally, the definition of a horizontal asymptote. Y equals L is a HA, horizontal asymptote, if the limit of f of x as x approaches negative infinity is L, or the limit of f of x as x approaches infinity is L, either negative or positive infinity, that makes the case then. Finding limits by numerical, graphical, and in fact, analytical method. Let's get the concept started. So we are interested in finding the limit of this function x minus 1 over x squared minus 1 when x is approaching 1. So we are getting started. So notice f of x is undefined. It's not defined when x equals 1 because the denominator becomes 0. Does it matter? And the answer is no. Why not? Because we are not interested in f of 1. We are interested in taking a limit as x approaches 1, which means we never get to 1. So numerical method, we're going to make up a table, and it gives us the value for f of x, and we want to go correct to so many decimals, but they are not equal to 1. We are getting close to 1, and we start from the left side, okay? Left side, for example, 0.5, 0.6, 0.7, 0.8, 0.9. And that's way too far from 1. So 0.99, 0.999, and we keep on adding. When we do that, the evaluation will give us this, and normally we should carry a lot of decimals. So I just want you to pay attention to the concept. Now, from the right of number 1, for example, 1.5, and let's get closer to 1 by choosing 1.4, 1.3, 1.2, 1.1, 1.01, and we pick up those values and we evaluate them. As we look at this one and this one, we notice the functional value is this when x is less than 1, but it's very close to it because this is the closest number to 1 from the left. This is among those. There are more. If I add more nines, it becomes even closer. And among those, this is the closest number to 1 from the right. And if you compare these two, it appears numerically the answer is 1/2 or 0.5. Again, if you have any doubts, you can do a couple more and you see the answer. If we were to graph this, it becomes a rational function with a hole at x equals 1. And at this point, notice when we come to 1 from the left, from the right, here's from the left, here's from the right, here's from the bottom, here's the top, and we get to 0.5 or 1/2. However, the best approach would be algebraic approach. And the technique is if you plug in, you get 0 over 0, which is known as indeterminate. So the technique for a rational expression is factoring. So again, if I plug in, everybody, if I plug in, I end up with 0 over 0, which is an indeterminate form. We discussed the indeterminate form. This is one indeterminate form. We discuss indeterminate forms with more details later on. And so technique would be factoring. As you know, this is a squared minus b squared. A minus bx, a plus b. And now 1 over x plus 1, when we plug in, we get the same answer, 1/2, analytic method. So analytical method is the best method, everybody. Limit laws or limit properties. If the limit of f of x as x approaches a and the limit of g of x as x approaches the same number, if they both exist, and c represents a number, a constant, then these are the limit laws. plus, minus, product, and quotient. Those are four operations. Everybody's familiar with that, the main operations. The limit of the sum is the sum of the limits. The limit of the difference is the difference of the limits. The limit of the product is the product of the limits. The limit of a quotient or a ratio is the ratio of the limits. Of course, the denominator can't be 1. And this one says you can take the c out because it's a number. And there are more. But we do direct substitution. A continuous function at a has the following limit value. The limit of f of x as x approaches a equals f of a. And so we just basically plug in. So functions with the direct substitution property are called continuous at a. We plug in and we observe. Then we have a very interesting theorem called the Squeeze Theorem. If a function is between two functions, if g is between f and h, when x is near a, except possibly at a, and the left side, the limit of f of x as x approaches a, with the right side, the limit of h of x as x approaches a, are identical to L, then the middle one has the same limit, the limit of g of x as x approaches a, because L, it's called the Squeeze Theorem. And of course, the one-sided limit has been already discussed. A function has a limit at a if the limit of f of x as x approaches, this is read a from the left, and the limit of f of x as x approaches a from the right, they are identical. Then we say the limit exists. And it's important to know every number. If a number is negative, both sides is negative. If a number is positive, both sides is positive. The only number that we want to be careful is 0 because the left side is negative, the right side is positive. So let's find these limits. And I want to make sure we understand the concept. We are interested in finding the limit as x approaches 2. So this is the number of interest. So here's the left side of 2. Here's the right side of 2. And because we are interested in the limit, we are going to look at the one-sided limits. So from the left, we are in this branch. We are moving towards this point, and this point has the y coordinate 3. From the right side, we're moving this way. Okay, from the right side of 2, we are moving this way. We are moving towards this hole. And this one has a y coordinate 1. So the limit of f of x as x approaches 2 from the right is positive 1. Are these two identical? No. Therefore, this limit does not exist. D and E does not exist. Remember, the concept of a limit is we are not interested at that point, but rather close to it. Now, this means at 2, which means look for a solid dot, a point such as this one, and the answer is 3. So f of 2 exists, and it's equal to 3. That's why when you compare these two, they are equal. They might say it's continuous at 2 from the left. The limit of f of x as x approaches 4. Here's number 4. Here's the left side of number 4. Here's the right side of number 4. From the left side, we are moving this way towards this hole. From the right side, we are moving this way towards the same hole, and therefore the limit exists, and if you continue, you see the y coordinate of 4. So the limit of f of x as x approaches 4 does exist, and it's equal to 4. So again, left and right of 4 takes us to the same spot, having y coordinate 4. Now, what is f of 4? I'm looking for a solid point. I don't find any. It's not given to me. Undefined. Okay. All right. We want to find the limit of this function, r of x, as x approaches 2. So you look at number 2 from the left, from the right. I hope you see it's going down. From both sides of 2, it's going down to negative infinity. Again, take a look at the graph. What about 5? What is the limit of this function as x approaches 5? Any ideas? Is number 5. From the left of 5, from the right of 5, both of them go up to positive infinity. Now, negative 3 from the left. This is number negative 3, everybody. From the left, it's going down to what? Negative infinity. From the right of negative 3, that's the meaning of it. Limit of r of x as x approaches minus 3 from right. From the right goes to positive infinity. Okay. All right. What about the VA, vertical asymptotes? Since this one is negative infinity, x equals 2. Since this one is positive infinity, x equals 5. Since this one is negative infinity, x equals negative 3. This results in the same thing. Both of these give us the same thing, x equals negative 3. So this is x equals negative 3, x equals 2, x equals 5. And again, vertical asymptotes have equations. That's the definition of a VA, vertical asymptote. How do we find the limits? Just plug in and observe. When we plug in, what happens? Well, maybe we get to a number. So the limit of f of x as x approaches something is a number you're done. For example, A. Plug in. Maybe it gives you 0 over a number. It's important to know when we say 0 over a number, that means other than 0. That is 0. It may be the other way around. It gives us a number over 0. When you have a number over 0, it goes to infinity. But is it positive or negative infinity? You have to further investigate it, and I'll show you how to do that easily as we come across some examples. Finally, we have the indeterminate forms of you plug in, you get 0 over 0, infinity over infinity, infinity minus infinity, and there are more like 1 to infinity, infinity to the power of 0. There are other forms, and how do we deal with them? There are algebraic techniques depending upon what we are dealing with, and I will show you those techniques. Starting with this, the very first thing is we plug in. So plug in 0. When we plug in 0, what do we get? Anybody? When we plug in 0, this is 0. This is 0 plus 4. 4 square root of that, 2 minus 2 is 0. It's extremely important to say if we plug in, we get 0 over 0. We don't get 0. We don't get undefined. Okay. We don't get, it does not exist. We get 0 over 0, which is indeterminate form. Now, in the case of an indeterminate, what does it mean? Well, to me, it means more work. What do I mean by that? It means use some sort of algebraic technique to fix the problem. So in this case, whenever we have a square root, the technique is conjugate. What is the conjugate of A minus B? It's A plus B. What is their product? A squared minus B squared. Therefore, you want the conjugate of the numerator because it has a square root. And the conjugate of that, you change the negative to positive. And not only you multiply by it, you also divide by it. Again, because it's 0, 0, you do that. If it's not, you're done. What is this expression equal to 1? Otherwise, you can't just multiply by the conjugate. Now, remember, when you have 0 over 0, it is the 0 in the denominator that creates a problem. So you're hoping to get rid of that. Because of that, you are not going to multiply the bottom. You are going to just to write it as a product. But if you multiply the top, you get square root of x plus 4 squared minus 2 squared, which is x plus 4 minus 4. And again, notice the denominator, we don't do anything. Before we move on, I want to make sure we to remind everybody, this is always negative 4, which is different than this one, which is positive 4, okay? And it has got to do with the order of operations. 4 and 4, negative 4 cancel each other. X cancels at the x. And if I plug in 0 here, I get square root of 4, which is 2 and 2 is 4. So 1 over 4 is the final answer. Okay, everyone. What happens to the next one? I hope I put both of them next to each other. What happens to B and C? I hope you see that whether you have negative 3 from the right or left, the numerator is negative 1. The denominator is 0. But we want to discuss the difference. Let me make sure everybody understands why I say that numerator is negative 1. When you plug in negative 3 from the right or left, and you add it to 2, it's very close to -1. In fact, -3 from the right. An example of that would be -2.9. So it's like -0.999, but it doesn't matter. It's very close here. Whereas here, it's like -1.001, and it's very close here. However, when you have 0, you have to be very careful because 0 from the right has a positive sign, 0 from the left has a negative sign, and you don't know which one is which unless you check it. So how do you check it? Pay attention to the methodology that I'm going to show you. So I'm going to plug in an example of -3 from the right side. The right side of -3, you can even use -2 class, but it's way too far. So if you put -2.9 and for the denominator as it added to 3, you get positive 0.1. And so this is -1 over 0 from the right. Please understand the meaning of this. This means somewhere on the right side. If I use the left side of -3 as an example, -4, but let's get closer, -3.1. If I add it to 3, I get -0.1. And so this is negative. What is the difference? Both of these are infinity, but this is negative over positive is negative infinity. Negative over negative, this is positive infinity. This is the methodology you use to find. And I hope everybody is okay with the concept. We want to find these limits, and the first one, what happens if we plug in 4, everybody? If we plug in 4, if you plug in 4, you get 0 over 0, which is indeterminate, and you need to do more work. The technique in the case of a rational expression is factoring. What I want to mention, class, again, the problem is the 0 in the denominator. Because x is approaching 4, you should have a factor of x minus 4 in the denominator. If it were approaching 5, you would have a factor of x minus 5, 10x minus 10. But if we had -4, we would have a factor of x plus 4. The numerator easy, you take out the x. The denominator, I hope everybody remembers all the factoring, so I'm going to quickly remind you. When it's x squared plus bx plus c, you want two numbers. The product is c, namely -4. The sum is b, namely -3. And this is the factoring. As you can see, x approaches 4, so it has a factor of x minus 4. That should help you with the factoring. And so now, these two cancel each other. And if you plug in, you get 4 over 5 as the final answer. Part B, what happens when we plug in? If you replace the h with 0, you get 0 over 0. because you're dealing with the square root, you multiply by the conjugate of the numerator by changing this to a plus sign. You multiply and divide by it, and this expression is equal to 1. And so what we get is the square root of 1 plus h squared minus 1 squared, which is 1 plus h minus 1. 1 and negative 1 cancel each other. H cancels out the h, and the numerator is left with 1. If you plug in 0, this becomes square root of 1, which is 1. With 1 becomes 2, so 1 over 2 is the final answer. Part A, go ahead class, plug in, let me see what you get. If you plug in, what do you get?
Zero over zero?
No. You can't assume you get 0 over 0. Many times we do. But in this case, we get something else. Anybody? Just evaluate. If I plug in 6, this is 0. I get positive 3 at top, not 0. Say it again, please.
1/2.
Perfect. So this is number 3. And this one, 36 minus 42 plus 12. So the numerator doesn't change. The denominator is 6. So the final answer is 1/2. The point of this question is this. Don't assume things. You have to work it out. If you assume it's 0 over 0 and you multiply by the conjugate of the numerator, you never get to the answer. First, plug in. Now this one, plug in, what do you get?
0 over 0.
Beautiful, which is indeterminate. We get 0 over 0, which is indeterminate. This is a complex fraction. The technique for complex fraction is LCD, the least common denominator. As you can see, you have two fractions in the numerator. 3 times x is the LCD. So we're going to multiply the top as well as the bottom by that, because this is equal to 1 and this is acceptable. Now, before we move on, again, remember x is approaching 3 and we have a 0 in the denominator. So the problem is x minus 3. You never ever distribute. You just put them in the form of a product. That's for the bottom. The top, 3x times 1/3 is x. These two minus 3. And now drop the common factor of x minus 3. So you get 1 over 3x. Notice, I'm carrying the lim sign all the way to the end. Now that I'm going to plug in 3 and I get 1 over 9, I no longer carry the lim sign. Let's make sure we understand the graph. We are interested in evaluating the following limit, the limit of f of x plus 5, g of x as x approaches -2. We must use limit laws to separate them into limit of f of x plus 5 times limit of g of x, both of them x approaches -2. That's the first step. Can anybody tell us what is this? What is the limit of f of x as x approaches -2? Anyone?
1.
Beautiful, beautiful. So here's number -2 along the x-axis. When we go from the left side of that, by the way, the f function is the red one, the red graph. And from the right side, we are here. And in both cases, we are moving towards this hole. Okay, and it has the y coordinate +1. Now the blue function, the limit of g of x as x approaches -2. What is that? Anybody? This one? What is that limit?
-1.
Beautiful, beautiful. So from the left side, we are moving this way. From the right side, we are moving that way. Both of them are shooting for this point and this point as a y coordinate, which is -1. Therefore, 1 plus 5 times -1, the answer is -4. The limit of f of x times g of x as x approaches 1. Again, let's separate them first. The limit of f of x as x approaches 1 times the limit of g of x as x approaches 1. So we want to work on this, everybody. What is the limit of f of x as x approaches 1?
+2.
Beautiful. So let's look at it. Here's number 1, the left side of number 1, coming from the left side. Here's the right side of number 1, coming from the right side of the graph. And in both cases, this way and that way, we are moving towards this point, and this point has the y coordinate 2. What about this one? What is the limit of g of x as x approaches 1? What do you
Does
think?
not exist.
Perfect, perfect, perfect. Does not exist. Let's show everybody why this is the case. So tell me, what is this limit as x approaches 1 from the left?
-2.
Beautiful. So from the left, we are moving here towards this point, and the y coordinate is -2. What about the right side?
-1.
Beautiful. From the right side, you're moving this way towards this hole, which has the y coordinate -1. Since -2 and -1 are not the same, the limit for g of x as x approaches 1 doesn't exist, and therefore the same thing here doesn't exist. The limit of the product of these two, because one of them doesn't exist, their product doesn't exist either. I want to quickly show you a different approach with the same result. And the different approach would be looking at the one from the left and right. So let's take this limit as x approaches 1 from the left. So 1 from the left. And 1 from the left. This one, the left and right makes no differences too. But this one, the left, is -2. So their product is 2 times -2 is negative. Same thing now from the right. So this one is still 2 because left and right are identical, but the right for this one is -1. The product of these two is -2. Again, since they are not the same, the limit of this function as x approaches 1 does not exist. I want to add a couple more things for that to make sure everybody understands this with more detail. So what is f of -2? What is f of -2? Anybody? So we are looking at the red function. Here's the -2. We are interested in f of -2. That means this is a hole, that doesn't work. This is a solid point, and the y coordinate of that is the answer. So this is 2, everybody. That's the meaning of that solid point. What about g of 1? Anybody has that one for us? G of 1.
-2.
G of 1 is -2. Let's see why this is the case. 1, you're looking for a solid point on the blue graph, and this one has a y coordinate -2. So again, I just wanted to make sure we understand the meaning of the dots. And finally, what is this limit? The limit of f of x over g of x as x approaches 2. What do you think? Limit of the f function over the g function as x approaches 2. You can write it up. What is the top one? What is the bottom one?
I have a question about example 7b. Why did we use the open circle when we were doing limit of g of x?
Because when we look at the limit, we never get there. It's approaching there.
Okay,
See,
thank you.
the concept of a limit is that x will never ever be equal to 1. It could be 1.0000001, or it could be 0.999999, not exactly at 1. Okay, that's the concept of it.
Okay.
Sure. Anybody can tell us what this is? It does not exist. Why is that? Because when you look at the f of x and x is approaching 2, okay, so for this one, x approaching 2 is the y coordinate here. Whatever you read it, maybe 1.5. But for this one is 0, okay? And we are dividing by 0, that's why. The denominator approaches 0 while the numerator approaches a non-zero number, 1.5 or close to that, and therefore it doesn't exist. All right. I'm reminding you of the Squeeze theorem. And clearly, g of x is between two functions, 2x less than or equal to g of x less than or equal to x to the power of 4 minus x squared plus 2. For all x, we want to evaluate this, the limit of g of x as x approaches 1. In that case, you look at the limit of this one, the left side and the right side as x approaches 1 to see what's happening. So the limit of 2x as x approaches 1 is simply 2. 2 times 1, right? Let's work on the right side. Let's plug in 1 to the power of 4 minus 1 squared. They cancel each other, so it's just 2. Since they are identical, according to the Squeeze theorem, the limit of g of x as x approaches 1 is also the same number, namely 2. Prove that the limit of square root of x times the bracket 1 plus sine squared of 2 pi over x is equal to 0 when x is approaches 0 from the right. Now, this you have to get creative. So I'll show you methodologies and then you can use them when the time comes to handle this. So to get creative, everybody knows that sine is between -1 and 1. If that's the case, regardless of what you have as the argument of sine, this is true. So we're going to use this argument. Now, so we're going to make it look like this, everybody. Starting with the brackets, starting with sine, and now I want sine squared. So if I square all sides, this becomes sine squared, this remains at 1. Please understand, if sine is between -1 and 1, when you square it is between 0 and 1. Because numbers less than 1 can give you 0. So you don't want to be, under the assumption is between 1 and 1, okay? Think about, for example, 0. 0 gives you 0. Do you follow what I'm saying? So between 0 and 1 gives you 0 and 1, and -1 to 0 does exactly the same thing. We want it to look like this, add 1. Again, look at the brackets. What is missing? 1. So let's add 1 to all sides. This becomes 1. This becomes what's inside the bracket, and this becomes 2. Add 1. The next one, we want to multiply by square root of x. And remember, x is approaching 0 from the right, and square root of x, the domain is 0 to infinity, but from the right, it's always positive. So when we multiply by square root of x, the sign doesn't change. It remains less than or equal, because if it's a negative number, it flips over. So this one gets multiplied by this one, and this one, we put it in brackets, okay, times square root of x. Now, take a look. This looks like this. Now let's use the Squeeze theorem. Look at this one. Limit of the left side, the left function, square root of x as x approaches 0 from the right is 0. The right function, the limit of 2 square root of x as x approaches 0 from the right is also 0. Now by the Squeeze theorem, this guy will give us the same result. The limit of the square root of x times the bracket 1 plus sine squared 2 pi over x as x approaches 0 from the right must be 0 by the Squeeze theorem as well. We want to find this limit, the limit of 2x plus 12 over the absolute value of x plus 6 as x approaches -6. We are going to go with one-sided limits. And so we take the limit, same limit as x approaches -6 from the left. And I remind you that if you're dealing with absolute value of x, it's x. If x is greater than or equal to 0, it's -x if it's less than 0. If I replace this with x plus 6, then I replace this one with x plus 6, okay? So x plus 6 greater than or equal to 0, or x is larger than or equal to -6. Minus x So minus x plus 6 is less than 6, or x is less than minus 6. Okay. So if it's greater than greater than or equal to negative 6, we just drop the absolute value. But if it's less than that, we drop the absolute value and we put a negative in front. The numerator doesn't change. I just take the 2 out. I get 2 times x plus 6. The other one, if I drop the absolute value, this is minus 6 from the left. So we are here. We drop the absolute value and we use this one, everybody. We use this one here, okay, for the denominator. X plus 6 cancel out. We get negative 2, and the limit of negative 2, regardless of what happens, doesn't matter what happens here. By the way, this is limits. The answer is negative 2. Let's do it from the right. Let's do the same thing from the right. From the right, we use this one, okay? And we just drop the absolute value at the bottom and we take the 2 out. These two cancel each other. And the limit of 2, regardless of x approaching minus 6 from the right or left, makes no difference, is 2. And therefore, because the two are not identical, one is negative, one is positive 2, this limit doesn't exist. Now, again, this has got to do with understanding the concept of a one-sided limit. We could have also worked out this expression without the limit. It's 2 if x is larger than or equal to minus 6, and it's negative 2 if x is less than negative 6. Therefore, this limit is from the right, for this limit is 2, from the left for this limit is negative 2, and you get to the same result. If this works out and it's faster for you, that's absolutely fine.